Legacy Database Schema and Data for AI Engine Designing. Pradeep K. Suri. Author, researcher, and AI-DNN architect. AI Engine Architecture. The architecture of an AI engine in a team setting involves several key components and layers that work together to develop, deploy, and manage AI models effectively. Here's a high-level overview of a typical AI engine architecture. 1. Data layer. Data sources include structured data, databases, unstructured data, text, images, streaming data, and external APIs. Data ingestion, tools and processes to collect and import data from various sources. Data storage, databases and data lakes to store raw and processed data. 2. Data processing layer. ETL, extract, transform, load processes to clean, transform, and load data into storage systems. Data pre-processing includes normalization, feature extraction, and data augmentation. 3. Model development layer. Development environments, Jupyter notebooks, IDEs, integrated development environments, and version control systems. Frameworks and libraries, TensorFlow, PyTorch, scikit-learn, etc., used for building and training models. Experimentation, tools to run experiments, track results, and manage model versions, example MLflow, weights and biases. 4. Training layer. Compute resources, GPUs, TPUs, and distributed computing systems. Training pipelines, automated pipelines to manage the training process, including hyperparameter tuning and model validation. Scalability, mechanisms to scale training across multiple nodes or cloud services. 5. Model deployment layer. Model serving, frameworks to deploy models as APIs or microservices, example TensorFlow serving, Kubernetes, Docker. Deployment pipelines, CI/CD, continuous integration/continuous deployment, pipelines to automate model deployment. Monitoring and logging, tools to monitor model performance, detect drifts, and log predictions. 6. User interface layer. Dashboards, visualization tools for model performance, data insights, and usage statistics. APIs, REST or GraphQL APIs for integrating AI services into applications. 7. Security and compliance. Access control, authentication and authorization mechanisms to secure data and models. Data privacy, ensuring compliance with regulations like GDPR, CCPA, etc. Audit trails, keeping logs of data access and modifications. AI engine management. Managing an AI engine within a team involves several key aspects to ensure efficient operation, collaboration, and continuous improvement. 1. Project management. Agile methodologies, use Agile frameworks, Scrum, Kanban, for iterative development and rapid prototyping. Task management, tools like Jira, Trello, or Asana to manage tasks, sprints, and project timelines. 2. Team collaboration. Version control, Git repositories, GitHub, GitLab, Bitbucket, for code and model versioning. Documentation, maintaining comprehensive documentation for code, models, and processes, example Confluence, Notion. Communication, platforms like Slack, Microsoft Teams, or Zoom for team communication and meetings. 3. Model lifecycle management. Model registry, centralized registry to manage different versions of models and their metadata. Experiment tracking, tools to log experiments, hyperparameters, and results, example MLflow, DVC. Retraining and updates, automated retraining pipelines based on new data or performance metrics. 4. Infrastructure management. Cloud services, utilizing cloud platforms, AWS, Azure, GCP, for scalable compute, storage, and managed AI services. Resource allocation, efficient allocation of compute resources and cost management. DevOps practices, implementing DevOps practices for model deployment, monitoring, and maintenance. 5. Performance monitoring. Metrics, tracking key performance indicators, KPIs, like accuracy, precision, recall, latency, and throughput. Alerting, setting up alerts for model performance degradation or system failures. User feedback, collecting and incorporating user feedback for model improvement. 6. Compliance and ethics. Bias and fairness, regular audits to ensure models are fair and unbiased. Ethical AI, adhering to ethical guidelines and best practices in AI development. Regulatory compliance, ensuring compliance with relevant data protection and AI regulations. By integrating these architectural components and management practices, teams can build robust, scalable, and efficient AI engines that drive value and innovation. Effective management ensures smooth collaboration, continuous improvement, and adherence to best practices in AI development and deployment. Here is a brief explanation of the two tables dbo.mas01 and dbo.db01 and how they can be important for designing an AI engine. Table, dbo.mas01. Structure. br_id, branch ID, integer. sl_no, serial number, integer. Code, ledger code, varchar, 6. Date 1, date time. f_year, financial year, integer. md_1 to md_12, monthly data for each month, decimal, 12, 2. mtamd, total monthly data amount, decimal, 14, 2. mc_1 to mc_12, monthly counts for each month, decimal, 12, 2. mtamd, total monthly count amount, decimal, 14, 2. User_created, user who created the entry, varchar, 25. Date_created, date of creation, date time. User_modified, user who modified the entry, varchar, 25. Date_modified, date of modification, date time. Purpose. This table is designed to store detailed monthly financial data and counts per branch and ledger. Each entry includes information for a particular financial year and month-wise details. This kind of granular data can be crucial for an AI engine aimed at financial analysis, trend detection, forecasting, and anomaly detection. The AI engine can utilize the detailed monthly breakdowns to learn patterns, predict future financial performance, and identify any discrepancies or unusual activity. Table, dbo.db01. Structure. trxn_id, transaction ID, integer, pk. br_id, branch ID, integer, pk. STP, statement type, integer, pk. vrno, voucher number, integer. s_no, serial number, integer. Date 3, date of transaction, date time. SLR, serial ledger reference, integer. Code 1, ledger code, varchar, 6. Particular, particulars or description, varchar, 255. C_amount, credit amount, decimal, 14, 2. D_amount, debit amount, decimal, 14, 2. Code, code for transaction type, integer. Cost center, varchar, 3. CHQ_no, check number, varchar, 15. CHQ_date, check date, date time. D_type, document type, integer. F_year, financial year, integer. USR_ID, user ID, varchar, 15. Month, integer. E_time, entry time, varchar, 20. Up_USR_ID, updated by user ID, varchar, 15. Up_E_time, update time, varchar, 20. Doc_no, document number, varchar, 40. Do_no, delivery order number, varchar, 40. Do_date, delivery order date, date time. Do_date, due date, date time. Ref_trxn_id, reference transaction ID, integer. Ref_stp, reference statement type, integer. Ref_vrno, reference voucher number, integer. Ref_s_no, reference serial number, integer. Ref_date 3, reference date, date time. Ref_SLR, reference serial ledger, integer. Ref_code 1, reference ledger code, varchar, 6. Ref_particular, reference particulars, varchar, 255. Ref_C_amount, reference credit amount, decimal, 14, 2. Ref_D_amount, reference debit amount, decimal, 14, 2. Ref_code, reference code, integer. Ref_cost, reference cost center, varchar, 3. Ref_CHQ_no, reference check number, varchar, 15. Ref_CHQ_date, reference check date, date time. Ref_D_type, reference document type, integer. Ref_F_year, reference financial year, integer. Ref_doc_no, reference document number, varchar, 40. Ref_do_no, reference delivery order number, varchar, 40. Ref_do_date, reference delivery order date, date time. Ref_do_date, reference due date, date time. User_created, user who created the entry, varchar, 25. Date_created, date of creation, date time. User_modified, user who modified the entry, varchar, 25. Date_modified, date of modification, date time. Purpose. This table captures detailed transaction records, including financial amounts, ledger codes, descriptions, and references to other transactions. It holds extensive data about each financial transaction, including credit and debit amounts, document details, and user information. For an AI engine, this table is crucial for understanding transactional behavior, generating insights into cash flows, detecting fraud, and conducting detailed financial analysis. The rich set of attributes enables the AI engine to correlate various factors, identify patterns, and make informed predictions or recommendations based on the transactional history. Importance for AI engine design. DBO.MAS01 provides detailed monthly and annual financial metrics which are essential for time series analysis, forecasting, and trend detection in financial data. DBO.DB01 offers comprehensive transactional data that enables the AI engine to perform granular analysis on individual transactions, detect anomalies, and understand transaction patterns. By leveraging the data in these tables, an AI engine can be designed to deliver powerful insights and predictions, aiding in strategic decision-making and operational efficiency. Thanks.